Okay, so today's lesson we're going to do the trigonometry function of compound angles. So basically 6 formulas, and I'd just like to use this lesson to prove to you the 6 formulas and to derive the formula. And in the next lesson, I would like to show you how to do the questions using the formulas, right? So this lesson is just about a proof. I don't think it's the course requirement that you do need to know the proof, but I believe learning mathematics is very important that you know where the formula comes from. Not just learning, oh, that's the formula, but you actually know why the formula works and what is the reason the formula looks like this way. Right, firstly, what is a compound angles? A compound angles is like we have a multiple angles, they're either plus or minus, from each other. And how do we expand, trigonometry function with compound angles? So what we're going to focus on at the beginning is how do we expand this cosine alpha minus beta. Now the problem with that is this is not like algebra. You can just like using distributive law and it just times the cosine into the alpha and times cosine into the beta. So you can't write expanding the bracket like a normal algebra and by writing this cosine alpha minus cosine beta, and this is completely incorrect. Okay, this is really important. The reason for that you need to remember this is cosine by itself means nothing, right? It does not mean anything, and that is the angle here, so they have to connect it together. All right, cos by itself means nothing. All right, so this is not the right one to expand. Okay, so I'm just going to write down the first formula. The expansion of this is equal to cosine alpha cosine beta plus sine alpha and sine beta. You do need to memorize the formula because later when you're solving equations, when you're solving trigonometric identities, you need to know how to expand. Okay, you need to know how to expand this cosine bracket alpha minus beta. Right, so from here, this is the first formula I would like to prove, and then from here we can derive more formulas there. Okay, so let's start from there. Right, so the first thing I would like to do is to create a circle with the radius equals to r. Okay, let's just create a circle. All right, and after that I just need to create a horizontal vertical axis. Horizontal vertical axis. All right, so that's pretty good. X and y. Alright, now let's just pick 2 points on the circle and we call this is point A and that's point B. And then we're connecting point A with the origin and we're connecting point B with the origin as well. Alright, not so good. Let's just do one more time. That's better. I'm just going to remove that. Yep, okay. Alright, and then the angle for this point A is alpha, and the angle for this point B is beta, all right? So just pay close attention to that. The alpha is the obtuse angle, starting from this point here, okay, and all the way to the point A in the anti-clockwise direction, and then alpha beta is from the same point and goes to the point B. All right, now let's connect A and B together to form a chord. Okay, cool. All right, so now what we need is we need to use 2 sets of formula. The first one is the cosine rule, and the second one is the distance formula to represent the distance of AB. Okay, the distance of AB. So firstly, according to the trigonometry here, and according to the diagram, I would like to write down the coordinate of A. All right, the coordinate of A is R. Okay, R, which is the radius. Okay, so I'll just write down the radius is equal to r. R cosine alpha. Now remember, because the angle is alpha from point A, and then r sine alpha. If you don't remember why it is r cosine alpha and then r sine alpha, you do need to go back to the trigonometry topic and revise, okay, what's the reason behind. And then point B is r cosine beta and r sine beta. So these are the 2 coordinates. Now once you have these 2 coordinates, I would like to use the distance formula. All right, so distance of AB, and we're using distance formula, not using the cosine rule. Later we're going to use the cosine rule. All right, so distance formula. All right, to work out the distance formula of AB, okay, so let's try this. Okay, AB squared is equal to, distance formula is x1 minus x2 bracket square plus y1 minus y2 bracket square, and you have to, later if you want to find AB itself, you have to square root it. But this one we don't have to. So it will be r cosine alpha minus r cosine beta squared, because that's, this one is x1, that's x2. So x1 minus x2 and a square. All right. Plus y1 minus y2 square. All right, so that becomes r sine alpha minus r sine beta square. All right, so after that, we just need to expand. Yes, expand. Whew, let's expand that. All right, let's just take the r square outside and try to expand that. Okay, so that will give us cosine square alpha minus 2 cosine alpha cosine beta plus cosine square beta. That's the first one. Okay, and what I should do is I should just, let's just rewrite this. I need more space, so I'm going to start from here. So r squared, let's try one more time. Cosine square alpha minus 2 cosine alpha cosine beta plus cosine square beta. All right, and then for this part, all right, I'm just going to take the r outside as well, all right, to further factorize it. So I'm just going to save a bit of space. So I'm going to, all right, so that if you take the r, and then because that becomes a square, so if you take the r square outside, and you will get this r square here. All right, now that becomes sine square alpha minus 2 sine alpha sine beta plus sine square beta. Okay, all right. Whew. All right, now let's continue. That becomes r squared brackets. Now what I wanted to do is pay attention to these two terms, and then pay attention to these two. Do you remember from the trigonometry identity that sine square alpha plus cosine square alpha, what is that equals to? And what is cosine square alpha plus, what's sine square beta plus cosine square beta? So, all right. Now I hope you remember what is the, what are these two equals to. All right. I hope you remember the answer for that. All right, and then we minus 2 cos alpha cos beta minus 2 sine alpha sine beta. All right, now that is equal to 1. Okay. I hope everyone got that. Okay, that's equal to 1. Sine alpha square plus sine square alpha plus cosine square alpha is equal to 1. Sine square beta plus cosine square beta is equal to 1. So therefore, you've got 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. Right, now we factorize the 2 outside, we'll get 2r squared 1 minus cos alpha cos beta minus sine alpha sine beta. All right, so finally, we get to this step. So what? We still haven't finished, right? This is just the distance of AB using the distance formula. All right, distance of AB using distance formula. What I want to do is find the distance of AB using cosine rule. Okay, so it's a totally different, it'll be a totally different expression, but they are the same distance. So distance for AB, but this time we're going to use cosine rule. All right, again, I hope you remember what is the cosine rule. Okay, so it's c squared is equal to a squared plus b squared minus 2ab cosine c. That is the cosine rule. All right, so all right, let's redraw the diagram. All right, we've got this angle here in between of this is alpha minus beta. All right, the radius is equal to r and r. So if we want to find out what is the distance here, then it should be quite easy to do. All right, so ab squared, which is the c squared, is equal to r squared plus r squared minus 2 times by r times by r times by cosine bracket alpha minus beta, which gives you r squared, 2r squared minus 2r squared cosine alpha minus beta. Now, This is AB squared. After we're getting these two values, all right, these two expressions, they're both represented by AB squared. So that's also AB squared before. So we just have two totally different expressions, but they represent the same AB squared. So that means what we can do is equating them together. Okay, so make them equal to each other because they're just AB squared. Why not we just equating them? Okay, so if we make them equal to each other, we're going to get 2r squared 1 minus cosine alpha cosine beta minus sine alpha sine beta is equal to 2r squared minus 2r squared cosine bracket alpha minus beta. Alright, now, okay, we're going to simplify this. If we simply divide everything by 2r squared, so that 2r squared cancelled out, that 2r squared cancelled out, and that 2r squared cancelled out. Alright, so we're going to get 1 minus cosine alpha cosine beta minus sine alpha sine beta is equal to 1 minus cosine alpha minus beta. Alright, keep doing that. We can cancel the 1 and 1 on both sides. And then this is minus, minus, and minus. We can change all the minus to positive. So we're going to get cosine alpha, cosine beta positive plus sine alpha, sine beta is equal to positive cosine alpha minus beta. And hence we have just proved the first formula. Wow, okay. So that's how you prove the first formula using it's just using two sets of a way to find the distance of AB. The first one is using the distance formula, and the second one is using the the cosine rule to find the distance of AB. And they both represent the distance of AB, so they should be equal to each other. And from here you just prove the first compound angle formula. All right, let me prove the other 5 for you guys. Okay. Alright, so what I'm going to do is write down the first one. Alright, so the first one is cosine alpha minus beta is equal to cosine alpha cosine beta plus sine alpha and sine beta. That's the first one here. Now I'd like to do the second one. Alright, formula number 2. Okay, formula number 2. For the formula number 2, what I want to do is I'm going to start from the same formula, but cosine alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. But this time I would like to just change. Oh, I just create a different color here. Looks pretty. Okay, so all right, let's try this. We're just going to replace the beta to another angle this time, and I want to further prove that. Okay, so instead of using a negative beta, all right, how about I replace that by instead of using positive beta here, how about I'm just going to replace the beta by negative beta. All right, so let beta equals to minus beta, or replace. I should use the word replace. Replace beta, okay, by minus beta. All right, let's have a look at what happens. If I replace beta by minus beta, okay, so that becomes cosine bracket alpha minus minus beta, okay, because that beta here is being replaced by minus beta. All right, it's equal to cosine alpha cosine minus beta plus sine alpha and sine minus beta. All right, so that gives you cosine bracket alpha plus beta is equal to. Now from here, cosine function is cosine function is an even function, so therefore cosine negative beta is cosine beta. It is an even function. However, sine function is an odd function, so therefore sine negative beta is negative sine beta, an odd function. As you can see, everything is related from the previous topics we have learned. So that gives you cosine alpha, cosine beta, since they are equal to each other, it's positive. However, on this side here, that becomes a negative sine beta. So we're going to change that positive to minus. Minus sine alpha, sine beta. So here is our second formula. All right, so that's our second formula here. And that formula tells you what happens if we change the sign, all right, from negative to positive inside the bracket. And then it's really easy. We'll basically just change the sign here. All right, so that's the formula number 2. All right, so let's move on to the formula number 3. We've got a few more to do. All right, so formula number 3, another compound angle formula here. We're still going to start from cosine alpha minus beta. Okay, still going to start from there. Because that's our original formula, and we can manipulate that formula to get to different formulas there. All right, okay. So, what do we do here? Now the next formula is we need to change the sign. So I would like to know what happened to the sine formula. All right, what happened to the sine formula? And how do we do the sine formula here? So what we're going to do here, in this case, again, let me use a different color. Oh, that looks pretty good. Oh, different one, this one. So if we start from, like, for example, if I want to know what's sine alpha plus beta, how do we know what's sine alpha plus beta? We don't know right now, right? But we know one of the complementary angle formula, which is sine theta is equal to cosine bracket pi on 2 minus theta, or 90 degrees minus theta. Okay, this is the complementary angle formula. So from here, what I can do is I can change that into cosine bracket pi on 2 minus bracket alpha plus beta. Now you have to pay close attention to this. Very important. I'm just going to zoom in a bit. And let's have a look at what happened. All right, pay attention. Now what I'm going to do is remove the brackets. And then, this is really special now, I'm going to combine the first two terms, like pi over 2 minus alpha, together. Okay? All right? Now, I would like you to pay attention. This is my first angle. And that part is my second angle. So can I apply this formula now? Well, the answer is yes, you can apply the formula. So sine bracket alpha plus beta is equal to cosine, let's use the formula, pi over 2 minus alpha, cosine beta plus sine pi over 2 minus alpha, and then sine beta. All right, keep going. Now, what is this? That's the complementary angle again. That's just this formula one more time. So we're going to replace this one back. All right, so that gives you sine alpha, cosine beta. And then that's the complementary angle for cosine, so it becomes cosine alpha, sine beta. Okay? All right, so this is our formula number 3. So sine bracket alpha plus beta is equal to sine alpha cos beta plus cosine alpha sine beta. Obviously, I remember the formula, but yeah, you do need to memorize the formula as well. All right, so this is the formula number 3, okay? The component angle formula number 3. Oh, all right, keep going. Now, formula number 4 is pretty easy to do. Number 4, what we are going to do is replace, I'm just going to use another color, this one here. We're going to replace, okay, we're going to start from this form, so by the way, sorry, okay, let's just remove that. We're going to start from this form here, sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. And then we're going to replace beta by negative beta, the same thing we did before. All right, so we're going to get sine alpha minus beta. As you can see, I hope you remember, you realize what I'm doing right now. I'm just replacing that by negative beta, so we can get this second sine and compound angle formula. All right, so that gives you sine bracket alpha minus beta is equal to sine alpha, because cosine is all even function, so that's unchanged. And sine is an even function, so that becomes minus cosine alpha sine beta. Alright, so formula number 4 finished. Sine bracket alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. And that's formula number 4. All right. So we've got 1, 2, 3, 4. I think it's better just... Oh. Okay, let me just make a box around it so it's clear which one is the formula. Once we finish, I'm just going to list all the formulas for you. Alright, and you need to obviously memorize those formulas for you to do in the later questions here. Alright, that's formula number 4. Okay. Wow, okay, what else we need to do? Alright, formula number 5. Now we're going to go back to the tangent, okay? So the tangent one is pretty easy, all right? Because we know tangent is sine over cos, all right? So the tangent is really easy. Using that, okay? All right, so... All right, so formula number 5, the tangent one. All right, so what happened, to the tangent alpha plus beta? What is that equals to? Tangent alpha plus beta is sine alpha plus beta over cosine alpha minus beta, plus beta, Okay? All right, so now if we just use the previous formula we did, all right, let's expand both numerator and denominator. We're going to get sine alpha, cos beta, cos alpha, sine beta. I hope you realize the pattern. Sine, cos, sine. Next, cos alpha, cos beta minus sine alpha, sine beta. All right. Once we get to this point, what we are going to do is really important. I am going to divide, okay, top and bottom by cosine alpha and cosine beta. We're going to divide every single term by this, okay, the top and the bottom by this. All right, now to make this one really clear for you, I am going to divide it one after another. Okay, so you're going to use this term divided by here. And if you look at that, these two crosses out, all right, because they are the same. These two crosses out. So you have sine alpha and cos alpha left. So that becomes sine alpha over cos alpha. So I'm just going to write sine alpha over cos alpha. And we're going to simplify that later. All right, so do the same thing. All right, we're going to divide this term by here. Remember, we divide every single term, right? This term by this one. So cross these two out, and we have sine beta over cosine beta. Sine beta over cosine beta. All right, if we do the same thing for the numerator, for the denominator, we're going to get 1 here because they are exactly the same term. Okay, so we get 1. And then minus, for that one is going to be sine alpha, sine beta over cos alpha, cos beta. Alright, so I hope you still remember the trig identity. Sine over cos is tangent, so that becomes tangent alpha plus tangent beta over 1 minus tangent alpha, tangent beta. And that is the formula number 5. Okay, that's a formula number 5. All right, and the last one. Okay, last formula, formula number 6. And by now, I think you already know what formula number 6 is going to be. Okay, it's going to be the negative one. All right, now what I'm going to do is just save time a bit, okay? I am not going to prove to you what's a negative one, all right? What happened to tangent alpha minus beta, because you know that, right? We're going to use the same idea because, if we are going to do tangent alpha minus beta, it is going to be sine alpha minus beta over cosine alpha minus beta. And of course, you can just expand all of these and do the same thing like what you did before. And then, you know what? The answer is tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. All right, so from here to here, I would like you to do the steps, right? Try to work out what is the proof. Okay, so this is for you to do. Okay, I'm just saving a little bit of time, and you're going to use exactly the same way to do this one here. So that is the next formula. All right, so now we have 6 compound angle formula. All right, so let me list all the 6 formulas for you, and I'm going to show you a way to memorize the 6 formulas, right? I know you've got a formula sheet that you can use, but you just don't have time in exams to keep looking at the formula sheet. Trust me, okay? All right, so I'm just going to write down all the formulas for you, okay? So the first one, I will start with sine alpha plus beta. All right, for the sine, it's always the alternate, all right? So for sine, the order is not important. You can do sine first or cos first. It doesn't matter. But it's always in the alternate pattern. So it would be like sine alpha, cos beta, like an alternate pattern. And then once you start with sine, now then you're going to start with cosine. Cosine alpha, sine beta. Very simple and easy. All right, for the minus, well, if it's plus in the middle, it's plus. If it's minus in the middle, it's minus. It's the same thing. But for the cosine, it's different. For cosine, cosine alpha plus beta. How do I remember cosine? Firstly, it's minus. If it's plus in the brackets and it's minus outside. But how do I remember that? I just remember something called like cosine, sine. Cosine, cosine, sine, sine. Okay? So it's really easy. Cosine, cosine, and sine, and sine. And that's how I remember it. Cosine, sine, very simple and easy to remember. I don't know why I remember like this, but it just works for me, okay? And then I remember cosine is always the opposite sign, okay? So like if it's minus, it's going to be a plus. Sine and sine. All right, now the last one's the tangent. Tangent is a bit tricky because it's a fraction. So you do need to know especially the sign. Okay, for the tangent, the first one is on numerator. If it's a plus, then you just normally expand like what you normally expand using algebra. So that becomes 10 alpha plus 10 beta. And then denominator, if you had a plus before, then it would be a minus. So 1 minus the product of these two terms. So it's still pretty easy. And the last one is if it's minus, then for the numerator, it is going to be minus. And for the denominator, it's going to be plus. All right, like that. All right, so these are the 6 compound angle formula, okay? In the next video, I would like to show you how to use those formula to do the questions, all right? You do need to know how to use it to solve the problems. Just knowing those are the compound angle formulas is not enough. But these are so important. You need to remember those formula, please, okay? Compound angle formula. All right, I hope you're enjoying the lesson. Now, what I recommend everyone to do is try not, all right, watch this video for once and then try to do it from scratch yourself. See if you can prove it, okay? If you can prove all the formula from scratch yourself, then you will remember those formulas very easily. Trust me, okay? Try to do it yourself if you have time, but the proof is not required for the HSC, so you don't need to know the proof if you don't want to, but it's better to know it. That's how we study mathematics, right? Knowing the reason behind. Okay, I hope you enjoyed the lesson. Thank you.